Look up at the night sky. What do you see? Countless points of light, each one a distant sun. Many of those suns have planets of their own, worlds we can only imagine. For as long as we have been human, we have stared into that darkness and wondered. We have dreamt of traveling to those stars, of exploring new worlds and discovering what lies beyond our own small corner of the universe. This dream is woven into our stories, our myths, and our science. The nearest star to our own, Proxima Centauri, is over 4 light-years away. That means even if we could travel at the speed of light, the fastest speed possible in the cosmos, it would take us more than 4 years to get there. Our current spacecraft would take tens of thousands of years to complete the same journey. Albert Einstein's theory of special relativity is one of the pillars of modern physics. It states that nothing with mass can ever reach the speed of light. As an object accelerates and gets closer to light speed, its mass increases. But what if there was a loophole? One of the most fascinating and perhaps the most bizarre is the idea of negative mass. If you were to push an object with negative mass, it would accelerate towards you instead of away from you. In our everyday lives, mass is something we experience constantly, even if we do not think about it. A cricket ball has more mass than a tennis ball, which is why it feels heavier and requires more effort to throw. This property is called inertial mass. It is a measure of an object's resistance to being moved or having its direction changed. Imagine holding a ball made of this strange substance. Instead of resisting your push, an object with negative mass would actively accelerate into the force you apply. A planet made of negative mass, however, would do the opposite. It would generate a repulsive gravitational field. But in 1994, a theoretical physicist named Miguel Alcubierre brought the idea into the realm of real science. The genius of the Alcubierre drive is that the spaceship inside the warp bubble does not actually move at all. Imagine you are on a surfboard in the ocean. You are not swimming through the water yourself. You are being carried along by a wave. To create the wave, the warp drive would need a ring of this exotic matter surrounding the spaceship. Early calculations suggested that creating a small warp bubble would require an amount of negative mass equivalent to the mass energy of the entire planet Jupiter. We have absolutely no idea how to create negative mass or negative energy density. Consider a pair of particles, one with positive mass and one with an equal amount of negative mass, created spontaneously from nothing. The pair would move off together, accelerating indefinitely. This bizarre runaway motion appears to be a blatant violation of the conservation laws. One of the consequences of this is that if you can travel faster than light, you can also, in theory, travel backwards in time. Imagine you build a warp drive powered by negative mass. You use it to travel back in time to when your grandfather was a young man, before he met your grandmother. If they never meet, your parent is never born, and consequently, you are never born. One of the most promising places to hunt for signs of exotic matter is in the vast expanse of the cosmos itself. Cosmologists study the large-scale structure of the universe, mapping the distribution of galaxies, dark matter, and cosmic voids. This is attributed to a mysterious force called dark energy, which seems to act like a form of anti-gravity, pushing space-time apart. This is a state of matter where a cloud of atoms is cooled down to just a fraction of a degree above absolute zero. By carefully manipulating this condensate with lasers, scientists at Washington State University in 2017 were able to create a region within the fluid that exhibited the properties of negative inertial mass. When they pushed on this part of the fluid, it accelerated back towards the push, just as theory predicted. For now, negative mass remains where it has been for decades, a fascinating idea on a blackboard. Until a physicist can either create a particle with negative mass in a lab or a telescope spots its influence among the stars, it will remain where it has been for decades. The search will undoubtedly continue. We currently do not understand what makes up 95% of our universe. Who knows what secrets are hiding in that darkness? The search for a quantum theory of gravity, the holy grail of modern physics, could also revolutionize our understanding and open up possibilities we cannot even imagine today. For now, our journey to the stars will continue one step at a time. with missions that push the boundaries of conventional propulsion and robotics. We will dream of warp bubbles and cosmic tunnels, of a future where the vast distances of space become manageable. They encourage us to keep looking, to keep questioning, and to never accept that our current limitations are the final word. The quest continues.